Now in today's class we are going to do something. We are going to do trigonometry ratio, trig ratios. Now under this trig ratio we are going to be proving some things. Let's say we are having a right angle triangle like this, a right angle triangle. Let's call here to be opposite. The angle is facing this place, theta is facing this place. The longest side of it is hypotenuse. Here is the adjacent. Now if you remember what we have, something like SOHCAHTOA simply means S means sine. The S is equal to what? Is equal to sine theta, which means opposite over hypotenuse. Opposite over hypotenuse. This opposite over this hypotenuse is the sine there. Now if you also look at cos, C now means what? Cos theta. Cos theta means adjacent over hypotenuse. The adjacent over hypotenuse. Then if you also look at T, which is tan, T which is what? Tan theta. Tan theta is what? Opposite over adjacent. The O stand for opposite, A stand for adjacent. Now if you look at this from this SOHCAHTOA that we got, now we can use the rule of Pythagorean theory that states that opposite square means O square plus A square is equal to hypotenuse square. That is Pythagoras rule. Pythagoras rule. And when we divide, let's divide both sides by the hypotenuse square. Divided by h square, divided by h square, then divided by h square. Now you are going to have O over h, you square it, plus A over a, then you square it, is equal to h divided by h is what? 1. Meaning that O over h is what here? Is sine. You see it now, is sine. That means the whole of this place is going to be sine theta, then you square it. That's how we got it. Plus A over h is what? A over h is cos. You could see it is cos. Now say cos theta, then you square it, is equal to 1. Now you are going to have, when you square means sine square, meaning sine theta times sine theta twice, plus cos theta times cos theta is equal to 1. That is what you are going to have here. Now if I should times it, it's going to be what? Sine square theta plus cos square theta is equal to 1. This is the first trigonometry of trigonometry ratio. This is the first identity of trigonometry ratio, how to prove it. Now if I should divide equation 1 by cos square theta, let me divide equation 1 by cos square theta. Let's see what I have. Let's say sine square theta divided by cos square theta plus cos square theta divided by cos square theta is equal to 1 divided by cos square theta. Meaning I divided this equation 1 by cos square theta. Now if I should work on this, I'm going to have something in this format. I'm going to have something in this format, meaning that you are going to have sine theta over cos theta. If you square it, plus cos square theta divided by cos square theta is 1 is equal to 1 over cos square theta. Remember that if you should have something in this format, 1 over cos theta is going to be what? 1 over cos theta means 1 over cos theta is A over H. Now when you go to this, when you take this up, H times 1 is going to be H over A. Now inverse of cos theta is called sec theta, meaning that because of square, now we square it, that means it's going to be sec square theta. Let me square it. Let's just square it. Now the whole of this is sin theta over cos theta is going to give us tan theta, then you square it, plus 1 is equal to sec square theta. Now how do I get tan theta? I will explain how I got it. If you remember that sin theta is what? Opposite over hypotenuse is divided by cos theta is what? Adjacent over hypotenuse. Now when you work it, opposite over hypotenuse times hypotenuse over A, this and this cancel, you left with O over H. Now O over H is what? Tan. That is how I got this tan theta. Now therefore we are going to have tan square theta plus 1 is equal to sec square theta. This is second identity, second equation of it. This is the second equations of second identity of trigonometry ratios. Now let me clean this place so that we can easily work the last identity of trigonometry ratios. Now then we are going to be having, therefore we are having now tan square theta plus 1 is equal to sec square theta. You can call this one equation 2. Now also divide equation 1 by sin theta. Let's say now we're having sin square theta divided by sin square theta plus cos square theta divided by sin square theta is equal to 1 divided by sin theta. Now sin theta divided by sin theta is 1 plus sin cos square theta over sin square theta is going to give us cot square theta plus 1 over sin theta is equal to, equal to 1 over sin theta is going to give us cosec square theta. Now how do I got this cot? I will explain. Now remember that cos theta is adjacent over hypotenuse, then divided by sin theta is what? Opposite over hypotenuse. If I should solve, I'm going to have A over H times H over O. H and H cancel. You left with A over O. Now the inverse of tan is called cot. Inverse of tan is cot. Now if I should have 1 over sin theta is what? Opposite over hypotenuse. If I should take this up, this time this is going to be what? Hypotenuse over opposite. Now inverse of sine is called cosec theta. The inverse of sine is called cosec theta. Therefore at the end of the day, this is how the identity how we got the identity. Now therefore the first identity now is what? The first identity is equation 1. Now the identity, now the trig identity, you can write trig identity. We have 1 sin square theta plus cos square theta is equal to 1. Second identity is, you can say tan square theta plus 1 is equal to sec square theta. The third identity can be 1 plus cot square theta is equal to sec square theta. These are the 3 identities of trigonometry ratio. In our next class we are going to be proving. Thank you.